So, happy Labor Day. Are you staying cool over there? I know it's
Relative to some, man, it is oppressive.
it's hot. It's a
Yeah.
lot hotter. It's a lot hotter inland, but it is definitely warm. Okay. Well, not to be too. I guess we're already on brand. We're complaining on Twitter Spaces, but to continue being on brand, I realize that I have been mispronouncing this word my entire life, I think. So first of all, how do you pronounce this word?
Potpourri.
Stan.
Potpourri.
Potpourri.
It's potpourri,
And-
where I'm from as well.
Potpourri.
And I think what I have been doing is I have been pronouncing a T. I have been saying potpourri, but if you say it quickly, it just sounds like I'm pronouncing it like everybody else. If you say
You have to be
potpourri,
saying it pretty quickly.
potpourri, no, if I say potpourri, it sounds like I'm saying it quickly. It sounds like I'm not pronouncing the T, but I know in my heart I am pronouncing the T, and that's why.
Dan is just unmuting himself just so he can shut this down. You know that, right?
Yes. Well, I listen. Dan is going to write my hagiography. That's what he told me.
Everyone's got to roll.
Everyone's got to roll. So a word that was introduced to me by Alex Trebek, I feel.
Yes, potpourri. Yes, for sure.
Right?
But what did you get? Like the spoken? Did you get like the written version of Jeopardy at home? Like how did you not hear it pronounced?
I was hearing it pronounced. I just thought I was hearing a T. Like this one, I've got like less of an excuse. But I'm not saying potpourri. I've never said that.
Yeah.
But I felt it was pronounced like
pot de creme kind of
like
in that direction.
Yeah, like a POTUS kind of a thing.
I see. Okay.
Or FPOTUS, as we've been reading a lot of these days.
There we go.
FPOTUS. So I've been mispronouncing this word, I realize, but I think we've been a bit overdue to just kind of have a structuralist random. I just know what the history of potpourri on Jeopardy is. I mean, that's a goofy name for a category. You would think like miscellaneous would have been more accessible. I mean, there's got to be a story there, don't you think?
Exactly. Miscellaneous, I'm sure, was more accessible. Like, why would they do that? I know we got to get down to whatever the business is, but I would say that my favorite moment of Jeopardy, and I watched a lot of it. I used to pause it on TiVo so we could, make sure we got the answers or whatever. But was when contestants almost, either after or before Jeopardy, what showed?
After or before
the game show?
Wheel of Fortune.
Wheel of Fortune, precisely.
Okay.
Easy question. All the contestants were stumped. Time was ticking down. Finally, someone buzzed in, got it right. And Trebek goes, "Woo! I thought we were going to have to kick you all down to Wheel of Fortune."
That's great.
And it was the most wonderful trivia show burn that I've ever seen.
That is great. And like in an era before social media. So like, unless that's going to be like an evening news story, like that's kind of like a private moment. Like it was live TV, more or less. You had to kind of be there to observe it.
Right.
That's great. And Pat State.
It's not like Vanna is going to tweet at Trebek or something.
Do you think that
start some beef?
Did you know that Richard Scarry and Dr. Seuss hated one of his guts?
I did it, and I love it.
And in particular, I think Richard Scarry didn't really care about. He just didn't care one way or the other about Dr. Seuss. But Theodore Geisel viewed Richard Scarry as, I mean, just beneath the world. The fact that anyone did like very quotidian, like who, and I'm like personally, I love Richard Scarry, so I guess I'm on Richard Scarry's side of this. But
Oh, really? I was going to say, Ted Geisel, you got me, because, man, fucking Busy Town. Like, and
what's wrong with
how
Busy
many
Town?
times have I gone? What's wrong with Busy Town is interminable.
And everyone's got work in Busy Town. Like everyone has a critical role to play in Busy Town.
And you got like some 2-year-old with a
no one has been drawn with funny eyebrows or any kind of racial stereotyping in Busy Town. I feel like.
You got a 2-year-old with photographic memory. So if you try to skip a page to get to the end, he's like, "Daddy, hold on, time out. Skipped a page." I'm like, "Oh, did I? Jeez, again."
But like, I mean, you're finding Goldbug. Like, it's so much fun to find Goldbug in Busy Town.
Yeah. I guess the memory of Busy Town is better than the actual Busy Town.
I just think this is where I realized that, like, even though I tried to deny it, in my heart of hearts, I just am a capitalist. I love the beating heart of Busy Town. I mean, its very name is so Calvinist. It's got the Protestant work ethic. It's like, I love it. It's like
it's right next to Taylorville.
It's exactly right next to Taylorville, where we're doing time measurement studies in Busytown, making sure that also you gotta love the fact that the butchers are all pigs in Busytown.
It is macabre. Yes.
It's genius, I think. But so what I'm wondering is, like, did Alex Trebek and Pat Sajak have some like fierce hidden rivalry?
I choose to believe that.
Or is it like a Ruth Bader Ginsburg, Clarence Thomas thing where they're like going golfing, whatever those two were doing?
Secretly buds. Yeah.
It's just like
wasn't that Alito?
They're all like,
I think it was Alito. But who knows? Maybe Thomas liked to go golfing with RBG as well.
I would read a book on this, is my point. Which brings me to the next question. This has been plaguing me all day. The book, Losing the Signal. Did I get how do I have this book in my possession? Did we talk about this here?
I don't remember talking about that.
So this book's extraordinary. It's on the rise and fall of RIM. It is so good.
Maybe we did talk. We definitely did talk about RIM, on and off over the decades.
We certainly have talked about RIM, but I actually wish that Amazon time-stamped your order history, because I know I ordered it on like I ordered it before we did our Books in the Box Redux, so it's not there. I don't know where I got this from, but it's really good. It's Losing the Signal, and they're turning it into a movie apparently.
Wow.
Yeah.
Okay. A biopic.
A bio
of a sort.
A bio pause pick. Yes. No. Yes. Well, so I've told you about my meeting with them, right? Have I told you? I'm sure I've told you this.
You did. Yes, you did. In disparagement of another particular company, which may have been more successful.
Yes. And did we talk about? I can't remember if we talked about that here or not.
No. Okay. No, definitely not. That's dry powder.
Okay, that's dry powder. So the context is, and then we'll get back on topic, whatever the topic is. On Potpourri. So this is in 2011, and all of a sudden RIM is very interested in acquiring Joyent, supposedly. And this is at a time when the Joyent CEO was at all times very interested in selling Joyent. So whenever there was this kind of interest, it was immediately like scramble. And Adam, how many times in your life have you like needed to be on the next flight to international destination?
Literally
really?
Never.
Oh, okay, yeah.
Never happened to me.
It's happened to me very rarely. And
yeah, you've worked for Crazy.
I definitely worked for Crazy. Oh my God, that is, yes, I did. I definitely did. So we need to be on the next flight to Waterloo. It's like 6 p.m. and we're like, we need to be in Waterloo tomorrow morning. It's like, okay.
It's like, well, then we should have left yesterday. I don't know.
Exactly. That's it. So we buy last minute red-eye tickets to go out to Waterloo. And we have these series of meetings in Waterloo. And like, this doesn't make any sense. Why are we here? Why would RIM acquire Joyent? And it's very clear over the course of talking to them over the course of the day that RIM is a total tire fire. This thing is an absolute mess. I mean, it's 2011. It is like June of 2011. The company is burning. And unfortunately, they don't know why they're interested in buying Joyent. And I realize that I am errantly suggesting good reasons that they could buy Joyent. And they're like, oh, yeah, no, that seems really interesting. Like, yeah, I like that. I'm like, wait, what am I doing? I do not want to be acquired by this company. This is like this is the Titanic engulfed in flames.
It's like it's like they were talking about that Titanic being insufficiently buoyant, and someone heard it wrong.
Right, totally. And so and as the day is going on, they also keep talking about the toy company. Like there's like a clear, I don't know if it's like, is this like a Canadian thing? But there's a nemesis. The toy company.
The toy company? I thought it was the fruit.
No, company. It's the toy company. And it took me hours to figure out what the fuck they were talking about. Because I didn't want to be like, who is there like some like has Toys R Us declared some sort of unconditional war on Waterloo? I mean, like, I'm missing a very important piece of context. And then at some point in maybe like the second or third meeting that this came up, so we're meeting with kind of all these underlings through the course of the day. And maybe sometime like just before lunch, someone mentions the Cupertino Toy Company. And I'm like, sorry, is the toy company Apple? I mean, I was just like gobsmacked. It's like,
do you mean the most valuable company in the world, probably at the time, if not like top 5?
right. And when this is like the company that's devouring you right now, like the company that has
people really love toys, man. I mean,
well, and it showed kind of their whole, I mean, perspective. I mean, which is always super, super dangerous whenever you have this kind of this broad within a culture when you're kind of denigrating not just a competitor but someone that's actually like beating you in the marketplace. And then so we finally had this meeting with them at the end of the day, and it was so weird in so many ways. One, the things that we had heard through the day had been kind of conditioning us for this meeting, which now make a lot more sense reading the book. And then we kind of the meeting was kind of performative. And what was crazy, so this is Lazaridis, Mike Lazaridis, and Jim Balsillie are the co-CEOs, like that ever works.
Already a recipe for success,
exactly.
Yes.
Red flags everywhere. And when Lazaridis was talking, Balsillie was rolling his eyes. It's like, hey,
like you're a teenager.
Oh, absolutely! Like get a load of this guy. Yeah, sure. All right, I'll be home by 11 p.m. Yeah, jerk.
Wow, jeez.
Is the death of empires.
Well, no, and it really. I felt like after that whole like insane episode, and which supposedly, I mean, I have the avarice of Joyent's CEO at the time to thank, because they supposedly were interested in buying the company, but not at a dollar figure that he was interested in selling at, which is God bless the greed. So did not get a chance to get taken on board the Kursk there. But it was, Danny, I think you're exactly right. I was like, man, how lucky was this to have been invited briefly into the wheelhouse of the Titanic? It was wild.
Real moment in time.
In time. But the book is extraordinary. Losing the Signal. But we have not talked about it here. So anyway,
on the topic of books, and actually something I want to bounce off of you. I've been reading for far too long because I'm a slow reader. The Masters of Doom. About id Software, John Carmack, John Romero, and terrific. I really enjoy the story. Book is a little inconsistently written. There's some shibboleths in there, like for example, when someone says, "I could care less," it really undermines, I think, the craft of the book for me as a fussy person. But there was this moment that it was describing, and I wanted to see if this resonated with you. But it was talking about some of the first networked gameplay. Chat, IRC, and some of this stuff of this era, sort of like the mid 90s, and describing these clans in Doom and Doom 2 and Quake 2 and so forth that had only communicated online, hadn't even spoken on the phone or whatever. And it brought me back to this moment where I realized that there was this moment as like a kind of young teenager or so, where these online conversations were really this moment of privacy that I had not had before. Where the phone was not a private thing, right? The phone was constantly in peril of like someone else picking up, because it was not my phone. It was like a phone shared with a house full of 4 people, and in some cases more. But it was sort of. I was thinking back to this specific moment as like the internet and BBSs and that kind of stuff unlocking privacy that I had not experienced before. This might have been a very narrow age band for which this resonated, because it may be that by the time you were on BBSs, you were already like in college and had all the privacy you needed.
I was on BBSs as a teenager. I feel like, I mean, a true. I was so off the leash at that point. I don't recall really yearning for privacy. I just didn't have, like, my parents were just
fair enough. Like
pretty much, like, I don't know, be home before dark. I just, but that is interesting about, and I mean, certainly I think it explains the enduring popularity of Snapchat, and the reason that Facebook, I think, has actually failed to ignite with teenagers is because of privacy. I mean, I do think that the teenagers today for sure want privacy, and they're much more mindful too of the fact though that things that they share, like they got you got a kind of privacy. You also have things that can be screenshotted that can come back to haunt you. So you definitely need to. The mics are all hot for teenagers. But yeah, it's interesting. And Masters of Doom is I've not read it, but I've heard great things.
Yeah, I'm into it. Like I mean, again, a little uneven, but the story is great. Just like John Carmack as this legendary programmer / abysmal coworker. It's pretty awesome. Just the kinds of stuff that he was getting these early PCs to do. It got me to one of the first things they did was, or one of the early things they did at id was port or make like a pirated port effectively of Super Mario Brothers 3 for the PC. Pitched it to Nintendo, and I ended up like pulling up a video that Carmack released or Romero released like 10 years ago. And it's pretty wild to just see what they were doing on a PC at a time when people did not think those things were really possible.
Not only did they think that they were not possible, and I don't know if they get this into this book, but graphics researchers were very upset because it's not possible. So graphics researchers were like, you can't, this is cheating. Like what you're doing is not 3D. And I think they were like, who cares? It's fine. Like,
close enough. Right,
exactly. Right.
Yeah. Matt, you were getting in?
Yes, so I've read Masters of Doom, or rather listened to the audiobook narrated by Will Wheaton, and I think that while the story is good, it's pretty light on technical detail or technical rigor. In particular, the description of of Carmack's first major breakthrough, where he got side scrolling working smoothly on a PC, was just really hand wavy. And I guess maybe that comes with writing for a general audience. But if you want a more condensed history of that period that paradoxically is also a little more technically rigorous, you might want to check out the series on. I don't know if any of you guys have ever read the blog, The Digital Antiquarian by Jimmy Maher. It's an ongoing history of computer games, and so like he started with, I think he started with Oregon Trail in the early 70s, and he's been going. He's up to 1996 now. He's been doing this for like 10 years, and he wrote a series of articles called The Shareware Scene, which started by talking about shareware in general, and then focused on id Software with their meeting at Softdisk, and then Commander Keen and Wolfenstein 3D, and concluding with Doom. And his description of how Carmack implemented side scrolling is more succinct, but also more technically meaty than what's in the book. So,
yeah, no, fair enough. I mean, it did definitely get me wondering what the actual technical innovation was, because like I was writing graphics code not that long after that, so could sort of see through to some interesting technical innovation there. The other thing that book called to mind that I had totally forgotten about was the first 3D accelerators, like the 3DFX card. I remember really pining after that in the early days.
And have you listened to the oral history with the 3DFX creators?
Oh, no, I got to check that. Is this Computer History Museum?
Computer History Museum.
Nice, I got to check that out.
Man, that stuff is so good. The Computer History Museum content is so. I wish they would make it available not only via YouTube, but there is so much good stuff out there.
Yeah.
Simeon. Simeon.
Yeah, on the topic of id Software and John Carmack, it's worth mentioning his .plan files. That would have been something that you would have found lying on a random BBS at some point. I guess it's pre-blogs.
Yeah, the book talks about that quite a bit, about how you're right. Like his .plan was like his Twitter or his blog or his Medium or whatever of updates for the day, bugs for the day. taking big shits on John Romero when he deemed them appropriate, that kind of stuff.
I remember
takes in the
reading
plan
one
file.
of Carmack's dot plans in '95 or '96 when I had just recently gotten on the internet, and for just because of my the way I started with BBSs and progressed to the internet, I learned about old internet kinds of things like Finger, and I think I actually read one of John Carmack's plan files back then using Finger.
There you go. I Finger, which to me is always going to be most famous for the internet worm. The hole that Morris found in Finger D.
Yeah.
Ian.
Yeah, I just wanted to say that John Romero has a book coming out next year, an autobiography called Doom Guy, Life in First Person. And I'm kind of looking forward to reading that to be able to see his perspective on the early id Software years, because it was very clear that there were some big personalities present in the room. I'm kind of curious to see his perspective on those things.
Yeah, absolutely. Amazon definitely got me with the same algorithm. I've pre-ordered that. I think it was supposed to be later this year, but yeah, it's pushed until next year. And a big theme in Masters of Doom is Romero being right at the front of the parade, taking credit for lots of stuff. So not surprised at all that he entitled it Doom Guy, and we will definitely. It'll be very interesting to contrast these two to see, if Carmack gets mentioned and what his role was.
Right. So in the index, no Carmack in the index. Okay, well, all right, I guess they did. Actually, Ian, while we got you, you mentioned when we did our Books in the Box episode, you'd mentioned Cyberville by Stacey Horn. Which I don't know if you read that. I got it on your recommendation and read it.
Yeah, I just finished it last weekend on a flight to San Francisco. So yeah, I have read the whole thing now.
I thought it was really interesting. So this is about, talk about like, Adam, because this is kind of this interesting bridge between, this is effectively an East Coast version of The Well that she was running called Echo. And this is all about kind of her. It's not like it's a memoir and it's pretty sloppy, but it is, I don't know, I found it to be really interesting. That kind of like early era, this is like earliest era social networking. And
yeah, definitely interesting. It was like part a New York in the 90s book and part computer, like a early social networking book. And there was definitely some lessons learned within that book that could have been learned through reading that book instead of learning through mistakes again for the era of social networking around the mid 2000s to like early 2010s. There's definitely some really difficult problems that they faced, yeah. and no easy answers to them, but they could have learned from that, I think.
Well, and I think it does show like just how endemic some of the challenges of social media are in terms like the challenges that we have are not new challenges, but she had all of the same kinds of, not all, but had many of the same kinds of things that would come to be really define the kind of the struggles that Facebook and others have had. But super interesting.
It was absent the like advertising network and data privacy problems that some of the social networks have experienced more recently, but it was very much a humans on the internet are still humans, and therefore the problems are going to be the same whether it's now or 20 years ago. Humans haven't changed that dramatically over the past 20 years.
Yeah, humans on the internet are definitely problematic is the conclusion of that. But anyway, thank you very much for that recommendation. I think it's pretty obscure. It's not, it was I had not heard of Echo at all. It was definitely interesting.
Yeah, it was only because of that broadband book. Yeah, right. About the contributions of women to technology over time. That was the only way that I found it.
The other thing that's super interesting, and the reason that like this book, like you absolutely could not publish this book today. It actually kind of reminds me of Paul's Boutique, Adam the Album, which is so like samples the Beatles all over the place.
Yeah,
like you could not make Paul's Boutique today because it was kind of like the medium was new. in particular, everybody on their social network on Echo uses their real name. And so she uses real names like throughout. First name, last name. And then along with like a dramatis personae at the end, just in case so you could like, these people are all readily Googleable. And I mean, it's just, I don't know, Ian, that must have struck you as well, because it's just like, wow, okay, we're going to like talk about a post that this person had from 1995. Okay.
Yeah, there was definitely very, very much a like, yeah, as I said, it's like New York in the 90s book where it's talking about like how these people's lives intersect with the social network rather than the social network itself. So it's like leans on that social aspect, and there's a lot of very explicit stories in the book about these individuals that I don't think that you would publish this book today with real names attached. But it's also just an interesting like experiment on what a real name social network looks like.
Totally.
Which we do have. I mean, Facebook people mostly use their real names, but yeah, it's very, very, very different to say Reddit of today or whatever.
But I just found myself yearning for like a symposium of these folks, because these are all like a half a generation older than I am. I think these are all, I think actually most of these, I think Horn would probably consider herself a young boomer, not an old Xer. And so this is like another 10 plus years older than certainly I am. And I would love to get this group of people together to reflect on what it was like then versus, what social networking has become.
Yeah, it's very interesting. I mean, it seems that the majority of contributors were in that mid 30s to early 40s range. It seemed like that was the bulk of their people in the early 90s. So there's they definitely would have had some very interesting experiences then, and to be able to reflect on, I mean, a number of them are on Twitter today, so it's clear that they've continued to use social media in some form or another. So it's like, it would be interesting to hear their perspectives on, social media over the past 25 odd years, and how it's changed, and what things that they think, they saw other companies making the same mistakes and be like, oh, okay, we went through that 15 years ago or whatever, or where they, where new things have come along and they're like, oh, okay, that's interesting. It's kind of like this that we did 15, 20 years ago, like that kind of stuff.
Yeah. I would love to get that crew together. That's going to be, Adam, I want to host a picnic for everyone who's on Echo.
Perfect. And we'll record it. Sounds great.
That's what I'm trying to say. All right. So we should probably get to some of the a couple of folks did actually ask us some pretty good questions. One, Matt, you had asked us a question about network storage, which I thought was particularly good. Do you want to go ahead and re-ask it and we can take a swing at it? If Matt's still here.
Sure. Sorry, just had to unlock my phone and find the unmute button. So the question is, I was looking around the Oxide website a little bit today because I knew you were going to do some Oxide Q&A, and I had one or two other things in mind to ask, to possibly ask about. But when I came across the storage page and I read that Oxide is using distributed block storage, I thought, well, wait a minute. What about back at Joyent when Brian and a couple of other people blogged in the wake of a big Amazon EBS outage in 2011, blogged about the perils of network block storage and a magical block storage abstraction, and then more generally about cascading failures. Because my understanding was that you guys at Joyent were all about local, direct attached storage on the compute nodes using ZFS, of course, and not the Amazon EBS type networked block storage. So I'm just wondering, and so I asked Brian if you had changed your position in the intervening years, which of course is a fine thing to do. or if there's something different about Oxide storage implementation that might resolve some or eliminate some of the old failure modes.
Yeah, it's a terrific question. I would like to say that in my blog entry talking about the peril of network storage, I did make a Simpsons reference at network storage, delicious but deadly, which is I believe that's a Troy McClure lead paint reference.
That's right.
And lead paint, let's face it, is delicious but deadly. Yeah, and I think a little bit of both. I think that it is definitely true that, and I don't think we have not found a way to square the CAP theorem, and there are still trade-offs to be made, and it definitely there is peril there for sure. Problem is, and actually this is what would be interesting to kind of expand on. The all local model has problems too, right? And the data durability is not so much of a problem, but availability obviously is a problem. That box bounces, your data is sitting there, it's nowhere else. And then the thing that was really kind of brutal that we found, and that I think, and Adam, you should obviously, take the wheel here, in terms of something that you and Josh have thought a lot about, and Alan. But the thing that was really tough at Joyent was doing kind of asset management with all local storage, and actually being able to migrating an instance is really, really painful. And when migrating an instance is painful, because you've got to move all the data, obviously, when migrating an instance is painful, you don't do it very frequently. And we ended up with a lot of problems that kind of cascaded from that. So that were kind of operational challenges. Now, the flip side of that is you don't have a network block store that everyone is leaning on. So there are lots of problems that we didn't have. So we're gonna flip the script a little bit, and we're gonna get rid of the problems that we did have and have a bunch of the problems that we didn't have.
Yeah, we'll try some different problems out.
Exactly. We can't hog the same problems again.
I think our position is broadly that it is still difficult, and if you can avoid it, you still should, but that we can't avoid it in order to deliver the features that we want. In particular, live migration of VMs is challenging when you can't just point at the storage from both the source and the target of a live migration. So,
well, not just live migration. I mean, even resiliency against a node failing, or resiliency against a single,
any kind of motion of VMs without needing to move the storage. Then, yes.
Yeah, right. Whether live or not live, exactly right.
Right.
Spontaneous migration.
Surprise migration.
Surprise migration, exactly.
All planned, but just not expensive. It's not expensive to move it because you don't move it. That's the and then.
And I mean, I think there are certain aspects of the problem that make it easier. One thing that's actually really important, Matt, and another kind of I don't know if this is you view this as a switch or a refinement, but definitely the hardware virtual machine has become the abstraction, and it's when we are not when you're deploying on an Oxide rack, you are always deploying on virtual machines, hardware virtual machines, which means you've got a clean block interface coming out of that virtual machine.
Well, wait a sec.
I know, right?
I know. Gave so many talks about running containers without VMs.
I did. I stand by my past selves.
This is a level calling for the ages, and Matt has the receipts.
Exactly. I think it's great. I honor the receipts. I mean, it's I've left a lot of receipts over this planet. So it's
right. There's a paper trail, right?
There is a paper trail, and so this is always on my. It's probably more of my. I mean, this is always on my mind. Of to what degree am I contradicting my past self? I mean, you also don't want to be kind of foolishly consistent with your past self. I do find it aesthetically at some level unfortunate. I think more so than displeasing. I think it's aesthetically unfortunate that we are recreating all of these kind of confining hardware abstractions. But I've also come to accept that that's the only real way. That layer, that hardware virtual machine abstraction layer, is actually our most important layer because it allows us to run effectively arbitrary software.
You mean the fact that the industry has standardized as on the x86 instruction set as the lingua franca, that is the unit of sort of compatibility across these different things. and we just sort of need to make it work on both sides.
Yeah,
I don't think it's quite even x86. Like, I think that there's room for ARM in the future, but it will still be partitions that look a lot like virtual machines we're delivering now. It'll just be, with an ARM instruction set in the future instead of x86.
Yeah. That's right.
Customers need to bring their own operating system image. I mean, that's really what it boils down to.
That's what it boils down to. And it's the thing that kind of is rotten about that is that there's at some level, like in particular, the use of DRAM. This is not a most efficient use of DRAM in that you've got the guest is going to ask for 16 gigs of memory or whatever, 8 gigs of memory. Any of its memory that it doesn't use, the hypervisor doesn't really have good visibility into that. So you end up with kind of isolated memory. The problem is that the alternative, and I think, Josh, is what you and I certainly lived, is where we make better use of available hardware resources also leads to less consistency. And when that cliffs out, it gets really ugly. So someone has gotten used to the fact that actually, my application actually is leveraging this DRAM cache that I'm effectively sitting on that I can't see. And when I'm the only tenant here, it performs really well. And then another tenant lands on this compute node, and all of a sudden it performs very poorly, and I'm upset. And that sucks. So it's a long way of me trying to square with my past self. How am I doing?
The Docker alternative, to me is even less appealing, that it standardizes on the Linux system call, table as the standard unit, which is, I don't know.
Oh, but you
more
guys
frustrating.
already did all that work to make it work through
did.
LX branded. And I'm not trying to give you a hard time about flip flopping for its own sake. It's just that I bought into what you said before.
No, I bought into it too. Listen, I bought into it too. So I'll tell you actually the true Waterloo on that. And I mean Waterloo in the not
the RIM headquarters.
No, not the RIM headquarters, exactly. But in the Napoleonic sense, the true Waterloo was when we had a regression. This application kind of had worked yesterday, didn't work today, kind of a thing. And it's all right, well, it was reproducible enough. The actual code was terrible. Some of the worst code I have ever seen as a customer's code. They didn't write it. They were using an open source package that was just I don't know. How do you express memory unsafety? I want to. I actually can't. I've actually tried to look for it. It's a very nondescript name. I swore to Steve that I wouldn't name and shame at the time, and now that time has long since passed, I wanted to go back and now is the time to name and shame, and I can't find it. But it is memory violent. This thing, it's the kind of thing. I don't know if you looked at code C or C++ code where you're that's a bug, that's a bug, that's a bug, but you know what I mean?
Yeah.
And in particular, what this thing was doing had it was amazing this thing even compiled, let alone did anything. And in particular, it had so many rampant memory violations, but that were happening by accident. And it was fishing effectively, not deliberately, accidentally, deep in its own stack and relying on the fact that this uninitialized value was 0. And as it turns out, we had made a fix that we needed to make that effectively pushed the stack up by 1 word, something that the operating system has an inalienable right to do. And it broke the application because now it wasn't getting 0. Now it was getting this, it was going from a fixed offset, so it was getting this other different value. And the app was dying. And it was one of these things where it's this is not resolvable. This is it. We are having to run it is really hard to run incorrect software with a porous abstraction layer. That's the problem. So,
you're saying VMs are a much tighter abstraction layer.
VMs are a much tighter abstraction layer, and the thing that sucks with that,
there are 500 system calls or something now, and some of those system calls open up fractally into its own space of system calls that all because Linux doesn't really do character device things. They do magic new system calls that effectively open what other operating systems might do with a character device. So epoll and event FD and signal FD and all these things. Yeah, it's one system call, but then you get a device that has its own entire behavior that you now have to emulate. And I think when we finally flew off the rails with namespaces specifically like mount namespaces, where like your temp and my temp and his temp are all different temps. Every process has a totally different VFS, basically. It's like, well, let's stop the world. I would like to get off.
Yeah, it's
So the myriad contents of anything under /sys or /proc or whatever, you have all these sort of, obscure files that have contents that are in some format which may or may not change, and you may or may not emulate faithfully, and God knows what's supposed to be in those things.
Yeah, and
The
if
system
you
interface is much
cat,
wider than just system calls.
that's right. If you echo some random bits into some random file, it changes some random behavior. Yeah.
yes.
What is swappiness anyway?
Truly, what is swappiness? And the virtual machine doesn't have these problems, right? The virtual machine is, for better and for ill, is a much less porous abstraction. And Adam, I'm with Josh. I actually don't know that that's necessarily going to be x86 forever. I think that could be ARM, maybe even RISC-V, with some kind of crazy alternate future. But I think it's probably going to be a virtual machine.
No, that's right. I mean,
Like a machine partition of some kind, like that. Yeah.
Yeah, no, VirtIO is more significant than the particular ISA for sure. I guess I just mean kind of this low level interface.
Yeah.
I mean, I'll tell you what. I mean, uniting these last two things. One of the things that really irritates me is that we've got a guest operating system creating a file system on top of block storage interface, which talks to some other file system, which is, chunking things up and spraying it all over, some NAND, which also isn't really speaking block. So you've got like these at least like 3 to 5 different re-divvying up information, all to emulate this interface that has really existed for 10 years and probably was antiquated. And like the biggest innovation we've seen in it is going from 512 bytes to 4K bytes.
Right.
I mean, you're describing modern hardware in general in many respects, but also it might be important to note that is an implementation artifact of our current implementation. Nothing prevents the guest from paravirtualizing and coordinating with the hypervisor and coordinating with the host software stack and coming up with a different abstraction.
I totally agree, Dan, and I think like some of those exist, but there's also a chicken or the egg, conundrum of who is going to, who's going to popularize what first, and how are we going to jump together?
Well, and ironically, if you do make the abstractions better, each time you do that, they become more complicated and more nuanced and much more like the Linux system call plane that we were trying to avoid emulating. Like the VirtFS stuff that they're driving over in Linux now to replace the 9pfs stuff to try and present a file system, like a hypervirtual, like a paravirtual interface to a host file system without an intermediate like block fiction. Ultimately is increasingly like, well, let's just do whatever like the vnode subsystem replacement in Linux does, and we'll just expose that as a direct like hypercall to the guest. The guest is Linux, right? It'll be fine. Like, I mean, it's so now you're emulating a really specific file system thing about which there are probably not that many stability guarantees long term anyway. As effectively like a whole new driver and like emulated hardware. It seems
so
block is at least just a big array of blocks. Like it's pretty hard to screw that up. I don't know.
Yeah, Tom, I know you. I was gonna. Tom, go ahead, because I obviously you've lived the history of NFS and all of this.
Yeah, I was just gonna mention that I've done some research into the origin of the 512 byte block. If you're interested.
Yeah, always.
Yeah, so I think it comes from the RK03 disk drive for the PDP-11, but it was also available for other PDPs. So it was one particular mode of it had support for 512 byte blocks, and it was physically identical cartridge to what IBM used on the IBM 1130, but for some reason they used 320 16-bit words. It wasn't a power of 2. So we have it all to thank the PDP-11 for.
And you said it's the RKIO? What was it?
RK03.
is the model on the drive,
RKO3.
which was predecessor of the much more popular RKO5.
Yeah, interesting. And so you say like Wi-Fi 12 versus instead of a larger size, presumably.
Yeah, they could have done. I mean, obviously, a power of 2 was convenient, and I thank them for that. But other people were squeezing more data out of the same drive.
I wish they had picked a power of 2 that was nowhere near a tempting power of 10 to avoid in terms of like lies that the industry tells. I do feel that what is a megabyte versus a megabyte.
It's pretty hard to say megabyte as an adult, and like in a professional set, I feel like it's a made up word.
There, you said it. I feel like that doesn't really come up in conversation for exactly that reason. Ian, you had your hand up.
Yeah, I was curious. So one of the challenges of running a large number of virtual machines is the management of security patches, because you have, a number of different OSs running in those different virtual machines, and you need to be able to make sure that they are keeping up to date on their security patches, and you can identify the nodes that are running a known bad version of the software that needs to be updated and that kind of stuff. Is there plans around building tooling to assist customers to be able to manage those security patches and manage the metadata around what OSs are running inside those VMs and what sets of softwares to be able to manage those security patches? Or is that going to be something that you continue to outsource to other software providers?
I think that's something that we're going to be in heterogeneous environments where people have VMware or GCP or AWS or whatever, and I don't think they want like a solution per cloud or solution per way of deploying instances. And we didn't need another big problem to take on between us and the initial ship. So I'd say that if customers come to us and say this is a big problem that they're hitting, yeah, like for sure we're going to do that. And if they say that they're happy outsourcing and want some heterogeneous solution, then maybe there's ways we can support that better.
I think something that we learned the hard way a lot at Giant, which has partly informed our choice to drive really hard on virtual machines, is trying to meet the customer where they are without needing to educate them too often, I think. And
we're going to experiment with that.
We're going to give that one a try. Like, so do you want to buy this and only this? Oh, all right. Well, but like critically, I think customers that have hundreds and thousands of VMs probably already are managing their software estate in some way. And I think that as much as possible, we're going to try and meet them where they are and let them keep doing it the same way that they would on a cloud provider or an internal VMware stack or something.
Well, I do think Adam, maybe it's worth talking a little bit about. I mean, this is not that we would have done it any other way. We definitely had done it this way in previous lives, but this is part of the reason we're API driven for everything. So it is actually easy to go build the customization on top of it.
Yeah, but for sure. Like anything that our customers can do through the console or through the CLI is also something they can automate. So, they can have at it. And I think we'd envision integrations the other way too, where, our console can drive other types of APIs in the fullness of time. If there's like some, third-party software like what you're describing, Ian, that folks want to automate in some way as part of like a standard practice, like for all their instances deployed in Oxide.
Yeah, I guess the building block here that I guess that I would make the most sense here is like, is there opportunity to store, metadata is a bit of a dirty word to me, but data associated with particular VMs, so that you can potentially build this tooling on top of the Oxide platform rather than, having to manage the VMs in Oxide, but then you have to manage your own database to be able to then say this VM is running this particular piece of software or that kind of thing.
It's interesting, Inge, because lots of APIs in lots of different domains give you like a little bit of space to store some of your own metadata, like you're describing. And in almost all of those cases, you run out of gas. Whether it's they don't give you enough space, or you need some additional level of consistency between objects. So I think even these APIs that provide a little bit of glue, like you're describing, a lot of automation ends up needing their own key value store, their own database of some description.
Yeah, you can definitely
even as you get to
outgrow.
some,
You can definitely outgrow that kind of stuff. But I guess there's like, is there like a power up or a plug-in platform by which
the other
you
part
can
of it is
extend the Oxide control panel and be able to like embed additional software alongside the Oxide control panel, and maybe there's some rudimentary storage present there, but you can break out of that and do your own thing if you grow out of that. Like,
so
is that kind of extensibility?
We tend to be pretty like problem driven. Like customers say, we need to solve this particular problem, and then let's go build facilities for that. We tend to not build support for things that are not concrete, because I think we've seen too many times that support can end up being insufficient, even for the kinds of things that we sort of imagineered people into using.
Do you think of kiosk mode when you think of this, Adam?
I didn't, but that's a great example. You want to talk about that?
Yeah, so kiosk mode, because I do feel that as an engineer, you always have to resist the temptation of building something, especially if it's easy. This is where engineers get really, if it's easy to build, you're like, oh, I can build that quickly. So why not? And so we had, in particular, a customer when we were building a storage appliance, and they described, like, what I would love to be able to have is I want to be able to give the kind of this analytics display out to people on my team, but I don't want them to be able to do anything else. So I want like a kiosk, like of just analytics. Like, okay, so that sounds great, and it was super easy to go do. But of course, like nothing is actually easy, right? So it was like, maybe I think Bill was working on it for like a weekend, and then it was like maybe dragged into Monday or Tuesday or Wednesday, maybe a little bit. And then by the time you get kind of, everything integrated, it's probably a week of effort by the time you get it all done. And I don't know that anyone ever used it, ever. We definitely talked to the customer, like, who became a Big Fish Works customer, and we were the big appliance customer. We were asking, like, how's kiosk mode? They're like, what? Like, well, no, do you like kiosk mode? Like, do not know what you're talking about. And then we kind of explained it, and they're like, oh, okay, that's interesting. Why'd you guys do that? It's like, because we had a conversation with you, and you said that you'd like this. Like, okay, yeah, boy. I guess I say a lot of things. I don't know.
It's like, that was definitely an early lesson for me in product management, which is like, customers do say lots of things, and sometimes they even mean them, and like other times less so.
And it is really hard. It is. You kind of have to go to the real. So I think, kind of a long way of saying that, we try to go to those really acute pain points that, hey, if you do this, it unlocks me. If you don't do this, I've got no way of solving this. Versus like, I've got a way of solving this without this, but it's kind of ugly. It's like, well, okay, well then go solve it. Let's go solve it the ugly way. And once we've done that a couple of times, let's maybe invent a better abstraction. But I mean, there's no pat answer for this, right, Adam? I mean, it's kind of it's an art for sure.
Exactly, and some of it is we want to enable people to do as much as possible with our product, and then once we see where those things go, then making them easier. Like, as a concrete example, one of the things we've talked about recently is when inevitably something will fail in the rack, it will need to scream for help, and what's the mechanism by which it will scream? And lots of customers...
And we've settled on a speaker. We're actually going to mount the speaker onto the rack.
That's right. Actually, it's the other way around. The alarm is going to go off every 10 seconds unless there's a problem.
So instead of you screaming at the servers in the data center,
that's right.
The servers are going to be screaming back at you.
That's right. Little turnabout is fair play. No, so a lot of customers plug into ServiceNow or into PagerDuty or into lots of other kinds of notification platforms. And we will probably build integrations into all of those in the fullness of time. And in the meantime, we're going to have some webhook, and we're going to call that webhook. And we will probably, Brian, me, Josh, our service personnel, folks we haven't even hired yet, and maybe the customers themselves will build these integrations. And some of them might be amazing, and some of them might be a little bit janky. And once we see that people need this, and people have done 2 or 3 or 4 of them, then we'll build it into the product. But then it becomes really clear that if we build this meets a real need, rather than building some sort of bridge to nowhere.
There's got to be. Are there? I mean, I know there's like a bunch that's been written on product management, but I feel a lot of it tries to be a little too pat and kind of skirts this fundamental ambiguity, and that like there's not an easy answer to this stuff.
Yeah, I mean, I'm embarrassed how much I've read about product management, and I have not read a book I would recommend on it, and I've read like 4 or 5. No, just because it's hard, as you say, it's hard, and I think that we talked about Agile too much on this on this Twitter space at times, but I think that it's the same thing where if you get too focused on the ceremony, then you lose all of the texture of what you're actually doing, and only go through the ceremony. And I think that product management is really susceptible to that.
Well, I kind of feel like it's the kind of thing where I just want to read like case studies. Like I just like give me 20 case studies that show some good examples, show some bad examples. I mean, definitely feel like with RIM, I'm reading a big one where not really paying attention to what people want and then doing it in the wrong way. It's super hard. Matt, you got your hand up. What piece of my past is about to be dug up right now? We're gonna spin the wheel. I wanted to do that. Actually, I believe it is still the most viral tweet
I just realized I was muted.
That's all right. Go ahead, Matt.
No, nothing on your past this time. But were you serious
Adam's
about
past?
having?
That's right. You're so lucky.
Were you serious about having a speaker in the rack?
No.
We're
Okay,
running
good.
No. We have.
Important question though, because I mean, we do some things. So.
We have toyed with the idea of playing music through fan oscillation, but that may be a V2 feature because we've got some other higher priorities, if I understand correctly.
It is also the fan controller is really a spoil sport on that because it's a very fancy fan controller that actually limits the rate at which you can accelerate the fans. So it's actually hard, I think, to play. Why am I putting this challenge down? I'm sure we can find it.
Well, I'm relieved that you weren't serious about a speaker in the rack because I thought I was going to have to point out an accessibility issue for a different disability this time.
Yeah, exactly. Do not worry. No speakers in the rack. Only bullhorns. No, I'm kidding. Ben, your hand's up.
Yeah, oh my goodness. Everything that was said about project management is like in my life for the past couple weeks. So that was interesting to hear echoes. But a long time ago on the website, you mentioned something about like network monitoring of virtual machines inside the rack, which seemed very interesting for me. So I currently work at Redjack, which is a cyber resiliency company, and the whole business is collecting network information in order to build constantly up-to-date asset inventories. And what you were teasing and maybe aren't teasing anymore seemed really useful. So is that still in the works or what?
For sure, yeah. Adam, you want to talk about what kind of? I mean, I think teasing is probably the right verb for it, but we definitely we're really excited about it because we have an integrated switch, and because we control. I mean, it's a P4 based silicon, so we actually control both ends of it, and there's all sorts of interesting stuff we can go do, of which we are only going to scratch the surface, I think, in the immediate future. I think there's a lot of things we can go do. So, yeah, I would be excited to hear the kinds of things that it unlocks. To me, it feels like, and I always felt that. You remember the company Boundary?
Yeah.
And I always felt like Boundary was actually really neat and didn't really get traction for a variety of reasons, and not least of which some founder problems. But the technology itself was they did really powerful things with very basic information. So I think by having I mean, certainly I've got my own kind of thinking on it in terms of like just the real-time information. I think it's very helpful to know what's talking to what in real time. I feel that there is just a lot that you can go do with that. Go ahead.
What's interesting that at least I've learned is that a lot of companies in this space, there's a sort of there's sort of two interests. One is on up to date, and the other is like not up to date but accurate, right? And so that's what I'm mostly focusing on. That's what I'm interested in here, right? So our biggest problem that we have is basically if you put multiple things behind one IP address, we rapidly result to a bunch of guesswork to figure out what's actually going on, and then you end up with one asset in your inventory which is actually multiple things, or maybe you have the opposite problem. And this getting information at a different sort of layer of the networking stack seems really appealing to get that sort of accurate information.
I mean, it blows the mind how, with so much control and observability to so many different points in the stack, the kinds of questions we're going to answer is just wild. In version 1, I think we're going to see something fairly pedestrian, that we're going to put the basic pieces in place. I think over time, what we'll see is that same product management philosophy that we're describing, which is working with customers to solve their immediate, burning problems, and then extrapolating from that to say, how could we have enabled customers to solve those on their own? And how can we take those scripts that we've built and additional instrumentation we've done, or just analysis or visualization, and then wrap a product around that? So again, it will definitely be a little bit late at times, for the first customer to maybe hit a unique problem, but those will spawn, tools and visualizations and utilities that we know are going to be incredibly valuable.
And we have found this is the kind of thing that actually, because we had great reticence about integrating our own switch because, we're trying not to actually be 9 startups in one startup. We actually are trying to have a minimum viable product. But it's really hard. And on the switch, when we felt that we for a bunch of technical reasons, we really needed to integrate the switch. And the thing that was so interesting is I assumed that we were doing that like, okay, well, this is going to be tough because now this is a much harder sale for people, bluntly, because now like the networking group has got to be bought in, and what are they going to think? And when we talk to folks about the approach we're taking and why, and especially the fact that it does provide this foundation for network observability, it has a lot of resonance. So Ben, there's no question that like people are really interested in the problem that is being solved. And I think people are frustrated out there, and they're frustrated by this kind of switch layer. I'm sure you're frustrated by it as well, where you don't have the visibility that you would want to. Arista's original, what it made hay on was its programmability, and I'm not sure how much of that has actually really come to fruition versus kind of remained aspirational. Certainly, it remained aspirational for us at Troy. We're never able to really use it in that regard.
But the worst thing that I see is someone will try to stick our network sensor onto a packet aggregator that promptly rips all the VLANs off.
Yeah, thanks very much. Right.
Right. Thank you. Exactly. Right. But yeah, exciting stuff. We'd be definitely excited to get your thoughts on that for sure. We definitely need to do. We've got to get Rye on here, Adam, and do.
Yes, absolutely. Every time he gives a demo, we say we got to get him on here. We got to get him on here. This is our colleague. Yeah, we're working on networking stuff that each demo blows my mind just a little bit more.
But that's because he's not distracted by being on the Twitter space, I think.
Interesting.
I think that's why his demos are the best demos. He's not here.
Rye's terrific, and would love to. Yeah, we got to get him on here because he's done really interesting stuff and he can kind of expand at length. So we definitely need to. Simeon, your hand was up.
Yeah, I've been going to Rust meetups here in Brisbane, and I ran into someone who I probably just won't get into specific names, but it's somebody who's working on OpenTitan Rust stuff on behalf of a vendor. And I asked them, the talk came up, and I asked them, so these Oxide guys have gone and they've done their own thing, and why do you think that is? And their answer was, well, I don't really know what their drivers are, what their requirements are, but I get the impression that it's hard for a startup to invest a lot of time in these large sort of multi-stakeholder open source communities. And you, Brian, have spoken a lot about open source and how that's changed the world, and specifically in Oxide and your approach to open source. But you guys do invent a lot of your own open source. And I wanted to get your take on like to what extent do you need to have this by necessity have a not invented here syndrome kind of thing, because you just need to be able to drive towards your objectives, and you cannot actually afford to cooperate in these larger communities where there are competing objectives and you have to negotiate when maybe you just don't have time to do that.
Brian, I was going to offer to be crazy cop if you want to merely be bad cop.
Thank you.
What I would say, Simeon, is I think that's categorically false, right? Like that we participate in lots of different open source communities. Brian can speak specifically to Talk, but when we build our own thing, it's because we weren't able to find the thing that we needed to fit the role. And I'd say, Josh could also speak to this. He invests a huge amount of time in open source communities to make it work. When in some cases, in hindsight, it feels like it might have been an easier path to go our own way. So we do lots of stuff with open firmware. We're working with lots of different folks in lots of different communities. I think there may have been a little bit of FUD associated with that response, in that, like, as a startup, we can't afford not to participate and use and collaborate in the open. All right.
We put a lot of effort into getting first-class Rust support for Illumos, for instance, and then a handful of us have wandered the countryside for 2 years, getting small patches into crates all over the ecosystem that we didn't write the crates, just adding support for things that we need. It's not particularly glamorous, but it's also not something that makes the papers. We participate in a lot of existing projects.
Yeah, so I think first of all, boy, that Adam is a real hothead, huh? Well, he's gonna take a walk, and now you're I think that Adam is right. And there's an entire spectrum of activity that we have, and I think Josh is right too, that the community, so for example, we're using Cockroach. Right, we are not 100% not reinventing Cockroach. Dave Pacheco's got a great kind of document documenting that whole exploration, and you'll see us just participate in that community where we have definitely hit issues, and we collaborate with
bugs, and we diagnose issues, and we deploy the software.
And that is kind of so we Cockroach and ClickHouse are probably at kind of one end of we're pretty much just using these things, participating a little bit. Things like Rust, I would say we are using, and we are trying. We do participate in a decent amount. Obviously, we Steve Klabnik was a Rust core contributor. Rust is extremely important to us, and really we are very, I would say, active in the community. We find regressions. I would say Lukeman finds regressions. Lukeman is always seems to have an exact bead on kind of what broke where. So that's a kind of a community that I would say we're very active in, although be it a broad and diverse one. Things like ProbeRS that we use for which is super important for us, and that's one where we've sometimes had frustration with, and sometimes been is this consistent with where we want to go? Is it not? And we come to the conclusion that this is consistent with where we want to go, but it's something we constantly reevaluate. I think in Talk's case is kind of at the Talk. I would actually say that, and Adam, correct, crazy cop, correct me if you disagree, but I actually think that we arguably erred by being too invested in Talk for too long. I was really reluctant to walk away from Talk.
We really wanted to make it work. We really did. I think we saw, early on. This is one of the first things I did at Oxide. I think probably one of the first things you kicked the tires on, Brian. But we wanted to make it work. It really seemed like the stars had aligned. Phil Levis, who's the professor at Stanford, who did a bunch of organized a bunch of work there, is a guy I went to school with. I think Brian, you overlapped with him as well. Like I'm kind of buddies with Phil. We wanted to make that work.
We went to the Dagobah system. We went to go visit Phil. We brought Phil offerings. We brought Phil a dead bird or whatever.
That's right. So I mean, we wanted to make it work. We were almost desperate to make it work, and it was not the right fit, and not the right fit for a bunch of different reasons. Some of them having to do with hardware and the kinds of things that just the exigencies of our timelines, and some of them having more to do with some of the multi-party discussion that you're alluding to, actually, where not everyone was aligned on things where we had absolute clarity, and I think it was going to take a long time for them to get to clarity.
Yeah, and I think that, Simeon, if you haven't seen it, I would really strongly recommend actually the talk that I gave at NodeConf in 2017. A talk I did not want to give, but the person,
this is the breakup, right?
This is the breakup.
I love you guys, but no thanks.
Yeah. Well, and actually the thing that's so funny is that Charles Beeler, who was organizing NodeConf, really wanted me to keynote NodeConf, and I'm like, Charles, like, we kind of broke up with Node. Like, I don't know that I got anything nice to say. And of course, Charles is like, oh, then you definitely have to talk. Like, oh, that would be great. It's like, oh, come on. And it was actually I'm very grateful for him kind of pushing on it, because it kind of forced me to be like, all right, wait a minute, what actually happened here? What did actually happen with Node? And why did we break up? Because, we were so in love once. And what happened to us anyway, Node? And kind of reflecting on that and realizing that, like, actually there was a values mismatch. And the values for Node were not the values that we had for Node. And when there's a values mismatch, it's really tough, because values are often expressed as positives, and no one wants to say, like, oh, by the way, like, we're not interested in rigor. We're not interested. Talk is not going to say, we are not interested in your ability to debug the system. Like, that's not something that talk is going to say. But as a practical matter, when we were building infrastructure that we needed to be able to go debug talk, was zero interest in that. And that was a huge problem, a really big problem with talk in particular. And I think, there's things I like about talk for sure, but talk is designed to be a teaching operating system, and it is designed to, in fact, it's like almost its first class operation is the ability to load foreign binaries. And it therefore is agnostic about the language in which those binaries were written. And neither of those things apply to Oxide. We are not interested in running foreign binaries on a service processor. We are only interested in running binaries we know about. And we are not agnostic with respect to language. And in particular, an irony with talk is, like, the Rust user level support is really not very good.
Or at least it wasn't 2 years ago. I mean, maybe it's come a long way. I don't know.
Yes. Oh, look who's crazy cop now. I guess the role has.
Get off the phone. Okay, I'm back. Don't worry.
That's right.
Well, anyway, thanks for humoring my question. I mean, that's very interesting. I would take that then as your position is that a startup doesn't necessarily have to step away from open source communities as much as I was suggesting.
Oh, for sure not. And I think that I think that it is always a balancing act. And you've got some. And there's this whole spectrum of, like, we've got some open source communities that we participate in that it's like slam dunk. This is exactly, and I would say Rust is probably a really good example of that. We share values with Rust. And and so, I mean, in particular, like, I'll give you something that is super weird that's important to us is the dwarf support in Rust that other people aren't depending on the way we're depending on it. When that has broken, it has been really revealed that, like, this is something that matters to the Rust community, even if they're not necessarily using it, which is really great. And so, like, constantly evaluating, and I think actually this is important for, like, because open source is just another variant of a technological partnership decision. And you're building this thing out of all these other things. Some of them are open. Hopefully a lot of them are open. Some of them, in terms of physical components, are at some level, it's like it's being manufactured, right? And one thing that we look for all of those is, to what degree do we share values? To what degree is the values of this thing represent our values? And sometimes we get that right out of the chute. We try to get that right out of the chute. And there have been plenty of times where we think this is a fit, and then we get in and discover, like, shoot, this is actually not the fit we thought it was. That fortunately has only happened a small handful of times. But it has definitely happened. So I think I think it's a great question. That would be my elaborate, too long answer to it.
One more good cop answer is that I think it is a common pitfall for startups to say we don't have time to participate. Like, we don't have time to give back. We don't have time to like show up to these committee meetings every 2 weeks or whatever. And I think that can broadly be true, but there's still some key areas, key technologies, key standards, or whatever, that it's worth that time investment. That it's worth kind of getting involved in those communities and steering them in wise directions.
Especially if
that seems similar to the tools. Sorry. Yeah, I just wanted to say, I mean, that seems quite similar to the time to build tools thing. Like, there's no time to build tools. No, don't get distracted.
Yeah, and I think it's also like the thing that's very important to take the time for is for setting expectations, I think. And I noticed that Rick is here, and Rick, I don't know if you wanted to talk a little bit about what we did when we open sourced Hubris, because one of the things that we really try to be very deliberate about is what people should expect of Oxide. Because I think if you set those, the more clearly you set those expectations, I mean, projects should be very overt about what's important to them, because it allows people to quickly make these decisions about whether that project is a fit or not.
Yeah, and I mean, coming back to like the general like why talk, I mean, Hubris is kind of the follow-on to that. And part of the decision making there was actually that we actually had multiple people on staff who had written bare metal real-time operating systems for that class of devices before, and we didn't want to do it if we didn't have to. There's a whole lot there, but certainly when we got to talking about open sourcing it, it was, well, why are we open sourcing it? Like, is this just to show off? Is this to actively encourage people to come in and foster a community around it? Is it to what is our top ideal, and how do we communicate that? Because otherwise you end up with oh, look, it's a company that threw this over the fence, and now that you can see it, but what can I do with it? Are they actually going to respond to pull requests, right? And so it's like setting up the expectations of, here's why we're doing it, here's what we expect in terms of, here's what you can expect from us, and here's what we expect of other folks who want to participate with it. And it's not a perfect process. Like, people are going to see the projects and make some of their own conclusions, regardless of what you write. But on the whole, we tried to set some expectations. No, we aren't going, like, we are building this to build our product right now, and we do want to see a community build around it, but we're not there yet. Like, we wanted to set that up front.
And I think this is very much a consequence of the previous lives we'd all lived, Rick. But in particular, I think that one of our problems with OpenTitan was there was lots to love about OpenTitan, but we, as just kind of a community member, couldn't get any visibility into when the ASIC was actually going to be available. I mean, that is ultimately, we had a lot of issues with talk. I mean, in the kinds of the talk and OpenTitan decisions were arguably could be made differently. But our problem with OpenTitan in particular was really just like, when are we going to have an ASIC? And because
that is very interesting.
And worth noting, OpenTitan is the hardware root of trust that came out of Titan from Google. Titan is the security chip that's in Chromebooks and other stuff.
And Google has been the leader on this. Google and Apple have been really the leaders on this. So we were very excited and wanted to participate, but it was really, I would say that maybe it was a model of not really setting expectations for community members in terms of like, okay, how can we participate and how can we learn more and how can we build a product around this? And it was just it was pretty clear that was not going to be a fit.
And just to get Crazy Cop back on the phone, I think sometimes you have bigger companies open sourcing technologies and then steamrolling the little ones. So I think in this case, as we try to engage with this community, we certainly did not have equal voice, nor necessarily should we have, but that became very evident.
Yeah, absolutely. Actually, that's a dovetail to there's another good question that was asked online about like what were the big technical challenges that we had at Oxide, which I thought was a really good one. Be interesting to get everyone else's answer to this. I mean, we've got some like immediate, like super scary technical challenges that we've talked about. Certainly the 499 ohm resistor that we needed on the Chelsea part, then the later 100 ohm resistor that we needed on the Chelsea part. Each of those resistors was the difference between life and death. The firmware issue on the Renaissance firmware issue where we were not implementing SVI2 properly, that was the difference between life and death. But I think the things we haven't talked quite as much about are some of the challenges that we had that were slightly more architectural. And, Adam, I don't know if you, Arian was in the office last week and he had an interesting line about, everyone thinks how great it would be to have a totally clean sheet of paper. But in many ways, those days were really, really hard because the problem was so unbounded and there were so many degrees of freedom. And I feel like there were a bunch of really tough things that we had to grapple with during that period.
Yeah. I totally agree with that. That I mean, on one hand, clean sheet of paper has a lot of affordances, but it's overwhelming, right? And at some point, you end up almost putting arbitrary constraints on yourself just to make some of these things tractable.
The one that always comes to mind, particularly, is NCSI and the which is the network channel sideband interface, right? Which is the ability to effectively control a service processor over your single high-speed link or your dual high-speed links, which feels like that's the way you'd want to do it, because the alternative is to have a second network just dedicated for service processors. And that was a really tough issue. Rick, do you want to talk about some of the kind of the gnashing of teeth we had on that one? Because that was in some ways the toughest technical issue I feel we've had from an architectural perspective.
Yeah, I mean, as you said, it's kind of it seems like the right thing you want to do. It effectively it lets you, NCSI is to let your BMC or service processor connect to your primary NIC in the machine, your Ethernet network card. And the network card then acts like a switch, a 3-port switch. So you have the outbound interface, and then you have the port that goes up to the host machine, and then you have a port that goes out to the management processor. And so you're like, well, this saves me a cable, and it saves me a whole switch, and it saves me a port, and there's a lot of good things out of it. But then you start digging into it, and like I had a lot of experience with it beforehand from prior research work and deployments. And so, we were talking about this, and it's like, wow, we could save a lot of cabling this way, all this stuff. And I'm like, yeah, but you really have to dig into how this is implemented, because here's this Broadcom gigabit network card over here that I know you can compromise the firmware from the host and then intercept all the management traffic that's supposed to be isolated from the host, because you actually get to man in the middle, right in between in the pipe. And so you get into these, like, this technology that seems great wasn't really architected thinking through security models, and they weren't designing for the types of isolation and functionality that you want. What happens in certain power modes. There's all these different edge cases, and you start working through it, and you start kind of looping back to, well, maybe I don't want this, right? And I think that's kind of, you see this even today, that NCSI is not, a big box feature that you're going to see on the side of a new machine, but it's also one of those where you can still see in designs today where the OEMs oscillate between, is this a good idea or not? And a lot of times they actually offer sort of a halfway, where there's like a config option that leaves it up to the customer to decide what to do, which is actually kind of the worst possible option.
I used to say at Sun, we're confused so you don't have to be. And I feel like this is like, we have outsourced our confusion to you, the customer. The customer's like, oh, what? And then it's like even worse, because it's like, okay, so if I turn this thing on and it doesn't work, like, how supported am I? And the answer is kind of like, well, not very. I think, and Rick, I don't know, as I was trying to think about like how this was a really thorny issue, because both alternatives were so bad. It is like, there's not an easy path here. And what is kind of like the easier path from the component perspective is a much darker path certainly from a firmware perspective and vulnerability perspective. And what is an easier path, what is kind of easier to wrap your head around, is super complicated to have a second switch. And, Rick, it would be interesting to know kind of your perspective on it. I felt like it was when I thought we did a good job of all right, we need to make forward progress without knowing, we all kind of agree that NCSI is problematic, but it also feels like, can this work? Because I thought that was when we were asking vendors some pretty pointed questions about NCSI, that's when it really all came crumbling down. This is not something that any of the vendors really.
Not really good.
The answers were terrible. The answers were terrible, and I think it kind of began to break under its own weight. Is kind of my recollection of that, Rick. I also remember it was super hot that summer. I can't think. Adam, were you in any of these discussions? These were we had. I mean, it was some.
No, I steer clear of those.
Oh man, they're brutal. Just because it's brutal because there's no good alternative, and it was just tough. And
the characteristic though that I think is really important between the two paths though was that I think we looked at them, and yes, both paths in the end would be a lot of work, and that the solution in neither path is a particular slam dunk. But the one that we picked, I think, highlights the sort of decision we make often, which is that we've picked the way that is hard, but where a lot of the work is sort of up to us. So at least
that we control our own destiny.
Yeah. Right, we can control as much of the firmware as possible. Yes, we have to put more switches in there, but we can pick the switches and we can write the software and we can debug the software. And we're kind of not beholden to the firmware in the NIC doing the right thing and then not being able to fix it when it doesn't.
Well, we're beholden to different firmware. I mean, this is there is the 8051 that is in the VSC 7448 that we've got to take this opaque blob and upgrade to. But
it was a good theory.
If I remember timing wise, this was also, we were having the discussions about NCSI, and we were really caught up on, and we wanted to go with NCSI to reduce cabling challenges. And that was around the same time where we came up with the idea of, well, what if we actually just made it entirely blind mate with a cabled backplane? And that combined with the discussions we were having about the NCSI implementations in the NICs and what their firmware looked like, it was kind of like, wait a minute, if we just sort of punt this whole problem back and take a wildly different approach, suddenly having that extra cable isn't really a problem, right?
Yeah, that's a good point. I hadn't really, those are correlated in time, aren't they? I hadn't really put two and two together on that one, but yeah, you're right. That is about the same timing because that did, because I remember we had a lot of challenges with having separate service processor network, but doubling the cabling was certainly one of them. And with a cable backplane, it's kind of taking that one away. But I don't know, Rick, if there are other problems you can think of that are kind of that ilk. But that was what I thought that was really tough. No easy answer, both paths hard. And that was definitely, I felt like it was a month to get that all resolved, maybe more. I mean, it was a long time of researching both of these paths.
One other one that came up that I remember was when I first came in, when I first joined, there was this discussion about, from a serviceability standpoint, you want to know which machine is plugged into which slot in the rack. And how do you identify it? How do you know which of these interchangeable machines is there? And there were all these discussions about different communication schemes, different, physical layers, different software concepts and protocols. And I sat down and I'm like, well, from here, would it help if I just go through the list of things that I know has been tried and doesn't work and why?
Right. It was helpful, as it turns out.
Yeah, and that ultimately, that continued to progress for a very long time, and it still became this problem of it. It's still a hard problem of, assume you have a machine that doesn't power on. How do you know that there's actually a machine plugged in that slot? How do you relay that information to the operator? And ultimately it came back to things like, well, the cable backplane gives you some opportunities, and you can do, some careful design and sort of solve it in our own unique way. But I remember that just being a very long, drawn out thing of like, well, do you do CAN? Do you do LIN? Do you do, is like, what can you actually stick in here as a low speed bus that's going to work, that's going to offer you the ability to find this out?
I had forgotten about CAN, that we were, and this, I mean, I feel like with a lot of these, Rick, when you were talking about the various things that people had tried, I was like, all right, let me go Google that one. Let me go Google that one. Let me go learn about this one. Let me go learn about this. Is where this is one of those early conversations where I'm like, I just do not know how anything works, actually. I don't know any of this stuff. And it was very educational. And then what we ended up landing on in terms of LVDS, I also knew nothing about. And it was interesting to go learn about that, and then doing our own FPGA on top of that was super educational. The question that was asked online was the issue with the NIC the reason that it kicked off so much of the switch hardware development, or is that unrelated? In terms of like why the switch, the reason we did this, and again, this is where we're kind of victims of our previous scar tissue. But we had just found over and over and over again that the commodity switches in particular, and the inability to control that layer of the stack had really serious consequences for availability and so on. And we had all of these same problems that we'd had with the compute sled, we'd had with these historic switches. Adam, did I ever tell you about the Quanta switches that we had to use?
No. This is a joint. Oh, man.
So, okay, so Samsung is doing due diligence on Joyent. Samsung is going to buy Joyent, and they want to we want to do some real stress testing. Like, okay, that's great. Unfortunately, the only equipment that we have to do real stress testing on is this total garbage over here. So you need to stress test on this garbage. And so and there were so many problems. I'm sure twitching right now, just remembering all of so we had these, all of these Dell machines that had their batteries on the perks had all long since died. So the perks.
This, by the way, was when you were all still pretending that we didn't know we were going to get bought by them, that they were going to be a customer.
Look, this is a challenge for any. So this is true.
I mean, you did what you had to do, but it just, for some context of this shitty data center that we ended up in. Which, by the way, now that we've all moved on, I feel like the next pre-acquisition cloud is going to get to use our shitty data center that's left behind.
Yeah, that's right.
Yeah.
Yeah. So what Josh is alluding to is Samsung wanted to do all this technical due diligence, but we couldn't reveal to the company that they wanted to buy the company. So, but we were also a transparent company, and so we did message this, which is really a euphemism for stretching the truth, that this is a customer, not a potential acquirer. So, Josh, I'm sorry. I'm sorry for having misled you.
It was pretty thinly veiled.
Thanks, thank you. Always good to know that I actually am an incompetent liar. I actually do feel it's one of my more charming attributes.
Secretly, accidentally honest.
Exactly. But so they had us on this fleet of garbage with all of these bleeding perks that were complaining about how they needed to be replaced. And then, do you remember the Quanta switch that we had on there, Josh? That had this tendency to drop all routes to everybody for 30 seconds.
Yeah, but then it would be fine after that.
So this thing would go there's split brain, and then there is brain split into its atomic particles. So literally every compute node can communicate. No compute node can communicate with any other compute node. And this is a storage service.
Putting the P in CAP, I think. It's not just a theorem, it's a promise.
It is a promise. And so, and it was our software did relatively, okay,
given the circumstances.
But of course, they're just why is that? Why are we seeing these latency bubbles? And of course, when you drop and everything begins to ARP everything else to kind of figure out who they are, and there are all sorts of knock-on effects of doing that. And it's why is the switch doing this? This is actually not. On the one hand, yes, you want to be resilient with respect to kind of these some of these issues. But on the other hand, like this is a Byzantine failure mode. Like this is not something you should be able to engineer this out of the system. And so we'd had so many issues. I mean, God, with LACP, Josh, I'm sorry, I shouldn't be doing this. All the link aggregation protocol. Remember, Adam, and the
Not just that, but the other thing, what's the MLAG?
Yeah, MLAG. Yes.
The distributed made up LACP. It doesn't work. It just doesn't work. Don't do it.
Do not do it. Do not do it. And so we just found that like integrating and trying to integrate, even when you're using these are standard protocols or standard-ish protocols, they're often not implemented very well. When you've got issues with them, they are on a kind of a per switch basis. The vendor's not very interested in helping. And it's the end customer that's holding the bag of like, well, I've got like infrastructure that doesn't work and it's your software that's running on it. So it's kind of your problem. And it's like hard to argue with that. It's like, yeah, it is kind of our problem. And as long as it's going to be our problem, I think we wanted to have agency over and control our own fate. And I mean, I remember agonizing about that quite a bit, Adam, about whether to integrate a switch or not. And that is, talk about a decision that just have not looked back from.
Yeah, nailed it. I mean,
yeah.
In particular with the cabled backplane, like maybe that made it easy.
And it's funny because like the integrated switch definitely came before the cable backplane. I very much assumed we were going to do a traditional cabling in the cold aisle kind of a thing for months, long after we'd made that decision, long after we burned our boats on that decision. And it's kind of a good example of how taking a clean sheet of paper avails you of things that you don't have a way of getting otherwise, which I feel we've done a couple of times, which has been fun. All right, well, this has been, yeah, sorry, go ahead.
Do you guys ever have like a fear that, I'm pretty sure you have a fear that sometimes that you've bitten off too much, but like you have this promise, like servers as it should be. Do you ever think that like, okay, you're doing a great job at building a fantastic foundation for servers as it should be, but that's like 5% of the total problem? Just thinking about security as one aspect, like, so you're doing this great root of trust, but there's like so many other aspects. Like, do you see yourself thinking now about, the Oxide bug bounty program or things like that? And does the full scope of everything like sometimes give you paralysis?
For sure. The full scope definitely gives us paralysis. I think that the thing that we all struggle with, I and other folks definitely chime in, but I think part of what we all struggle with is we know where we want to take this thing and the kinds of things we want to be able to go build on it. And it's just going to take time to actually get there. And the product that we're going to have, I mean, the challenge of this company has been defining what that minimum product is and then getting that thing actually in the market and being able to iterate on it and improve on it. And that I feel is like the anxiety is not, for me anyway, is not, can we go build all this stuff? Because I know we can and will, and not have we bitten off more than we can chew, because yes, we have, but we also, we deliberately bit off, I think, the least that we could. It's more just
brings us back to product management, right? Like one aspect of product management is putting in order all of the things that you need to do, and then drawing a line between somewhere down that list as to like when you can stop to ship something. Like how far down this list do I have to get before I can sell this to our customer?
Right, or as a software that Josh and I are currently dealing with, like where on the list is the software that you need to be able to manufacture it? It's like, yeah, that's high on the list, as it turns out.
It's really important not to look at the whole scope at once.
I'm guessing you also need to figure out at what point can you like look other people in the face and say this is some minimum viable version of servers as they should be versus this is just a server, and it kind of doesn't entirely deliver on that promise.
Oh, I think we're gonna what we're bringing in. I mean, I think when we bring this thing into the market at the end of the year, I think we're going to have something that is a pretty clear and concrete embodiment of a very different way of doing a bunch of different things. So I'm definitely going to be able to look people in the eye and know that we've taken I think the challenge is more going to be as we go, there's a lot to go build. on top of that. That is not about, about functionality too, about kind of basic functionality. That's obviously the priority, but it's more than realizing the ultimate potential of this thing is that's going to be,
That's right. I mean, the first product is going to be coherent on its own. And there's lots of other stuff that we can do. Some of it we've even talked about on this Twitter space. But some of those things like the depth of network observability that we can build, or enabling other types of automation, those are kind of easy things to excise. Harder things to excise have been, or harder decisions have been like the one that Brian just described. Or, should we do hyperconverged storage or disaggregated hyperconverged storage? Like those have been some of the tougher ones. And in the future, we can deliver on this vision of what servers can be with what should function as a service look like, what should, container orchestration look like, enabled by these lower layers. But, what we've got in the first cut is like a sort of an easy place to stop.
Well, I think that also getting these lower layers right, you got to get the layers right that are going to be immutable in the field. So the hardware you got to get right, and you got to get the switch right, the backplane right. You got to get, so that way. I mean, for that reason, these issues around bring up have been kind of the most anxiety producing. And actually, there've been some really thorny issues there too, architecturally too. I think actually one of the biggest, gaps in where we felt that we could go and where we were going to be was around the mechanism by which, how can the root of trust prevent the service processor from actually running if it is not attested itself at some level. And the way we were originally doing that, it's like there was a window where the service processor was basically going to be off to the races because we're not interposing on SPI. Service processor is going to be off to the races, and there would be a window in which the service processor, a window that you'd want to minimize, but where the service processor there would be a gap in there of hundreds of milliseconds, seconds, and before the root of trust would be able to say, hey, wait a minute, this is not running the right thing, and bring it down. And that was really, really dissatisfying. Fortunately, Rick and Laura and Matt and a bunch of folks kind of been noodling on this for a while and came up with, I think, is a absolutely beautiful solution whereby we have the root of trust treat the service processor as a debug target using the SWID interface, which is the single wire debug interface in ARM, which ends up being super, I think, elegant. So we effectively bit bang the SWID interface. And we emulate that, and the SP, because that is a really, really robust interface, and that actually allows us to completely close this gap. So the root of trust truly controls the service processor, but without using SPI interposition.
So I do want to chime in because there was a mention of, like, on the security side specifically, of are we shooting too high, or are we going to, how close to our goal of servers as it should be will we get? And like, security is one of those really, really difficult topics of there is no way of achieving perfect security. And so you're always having to make that decision about where are you going to draw the line. But with a system like this, where we're really reimagining things at very low levels of the system, a lot of it is, how do we make sure that we get the right groundwork in so that we can, if we find that our thoughts about where we're going to go aren't spot on, like, do we leave ourselves a solid enough foundation that leaves us enough room to migrate in different ways and implement things later? There's definitely a challenge of how much do you have to build into the hardware itself, and when you fuse parts in the factory, that's your last chance. And so there's careful thought in those regards. But then there's high level things like, how do you do a bug bounty program? Well, that's a problem for later, right? Like, we don't have to do a bug bounty program. And is it even appropriate to do a bug bounty program for a product like this? It's hard to say, and it's things that we will have to figure out, but not yet.
Matt, last question. I think we'll probably want to wrap up because get Adam back to his toddler on a very hot Labor Day.
Yeah. So one of you guys mentioned storage again and hyper converged versus something else. So I forget what the other thing was.
Oh, it's disaggregated hyperconverged.
Right.
Yeah. Don't Google it. Right.
Okay. So back to Brian's old post about network storage in the cloud, delicious but deadly. One of the things, Brian, you mentioned in that post was the problem of running lots of VMs on a very small number of centralized, disks at the time, actual disks at the time. So are you guys so now with Oxide, are you guys using does every sled have an NVMe have NVMe storage, and is every sled serving as a storage node among its other duties, or how are you doing it this time?
Yeah, that's right. So we have one kind of sled. It's the kind of sled that has 10 NVMe devices, and it hosts both VMs and storage software, providing block storage it might be for some of the VMs that are running locally, or it might be VMs that are running on some other sled.
So then it's networked block storage, but it's widely distributed.
That's right. And then also with 100 gig backplane. So I hope to have a little more room there from a performance perspective, but we're not. And then I think also another big difference, honestly, between when I wrote that, I think in 2011, and today, is we're not actually hitting spindles for any of this stuff. So this is all flash, and those absolute numbers actually do make a difference. I mean, I feel like that one of my big pieces of education from having built a storage appliance with rotating media and then doing an object storage service again when we did it together at Joyent, the blast radius of a single bad drive is really impressive.
Well, Amazon EBS doesn't even have, at least to my knowledge, the kind of big failures that it used to.
Right, it does not, and for a bunch of reasons, a bunch of engineering reasons, I think that they spent a lot of time improving that, and then it also, I'm sure they've improved the substrate with a focus on not having those kind of arbitrary queuing delays. And then you also have to be careful about kind of when the system begins to reconstruct itself. This is when you can get into real trouble, is when the system is reconstructing itself automatically, and where arbitrary latency outliers can cause the system to start reconstructing itself. You can create a positive feedback loop where the system is creating traffic because of the amount of traffic. So there's a bunch of just gnarly implementation issues that you've got to square to get the thing to work at scale. For us, the storage is all going to come locally out of that rack. So every compute sled, as Adam mentions, every compute sled's got the NVMe drives. It is spread across the rack, but that storage is not going across the rack.
And every time that we feel like we're getting set in it, I just bring up some experience of running my Ceph cluster at home using spindles on a 10 gig network, and just, remind us of what the pain points actually are.
Exactly. A huge amount of engineering at Oxide is everyone pointing to their own scar tissue. Unfortunately, we've got a good union of scar tissue. I feel like we've got a lot of, it's actually always I actually love when, and I feel like this has happened a couple of times, when there's a technology area that people have explored from 7 totally different engineering cultures and all have drawn the same conclusion. It's like a 9-0 Supreme Court decision. It's like, this is just the truth about this thing. Everybody has drawn the same conclusion. We've got a couple of those, I feel.
Oh, speaking of blast from the past, when I think it was Rick mentioned a Ceph cluster just now, I was reminded of the blog post that Faith Life did, who I believe was ended up using a Smart Data Center at the time, did several years ago, about their nightmare with OpenStack and Ceph storage.
That is the Sat Apocalypse is the title of that blog entry, which is, Adam, if you read this one.
No, I gotta check it out.
Yeah, I got to go check it out. That's a good one. Actually, good note to end on, too. That's a good one to go check out. But it is, distributed storage systems are really hard and thorny, and I'm sure we've got plenty of failure modes ahead of us. But the flexibility that you get from it is just too compelling, is the short answer there. All right, well, Adam, this has been fun potpourri. This has been
Awesome. Like
I
quite the
hope
grab
the-
bag.
Yeah, quite a grab bag. And I'm gonna tease the future a little bit. I may have heard back from one of the co-authors of Losing the Signal, and I think we're gonna be able to get him on the Twitter Space.
Awesome.
So,
That's
yeah.
gonna be great.
So prepare for a RIM themed Twitter Space coming at some point to near you. All right, everybody, stay cool, and see you next time.